Okay, looking at the modeling problem solving solutions for the end-term diagnostic. The first question talks about the number of hours of daylight at a particular point in the Antarctic Circle, where we're going to get some really long days and some really short days. We have a function that's going to give us approximately how many hours of sunlight there are per day, where T is the number of months and D is the number of hours of daylight. So the question asks us to find the number of daylight hours on the 5th of July. So essentially we're going to have some graph. It's like D versus T, an average value of 12, amplitude of 12, and it's a positive cosine graph. So it'll look something like this. Over the period of a year, 12 months, it should repeat itself. So what we're trying to find is, on this particular day, on the 5th of July, we need to find whereabouts on the graph it is and how many hours of daylight there will be. So for part A, I'm really wanting to substitute in T equals whatever number month I'm up to. So I started at 1 January, so I'm going to February, March, April, May, June, July. So that's what, 1, 2, 3, 4, 5, 6 months. And I need to get to the 5th of July. So that's 4 days. So the time I'm going to substitute into the equation is going to be 6 months and 4/30ths of a month. Okay, I'm going to assume 30 days per month. If I want, I can simplify that fraction, make it into a decimal or whatever, but essentially I want to find what D of 6 4/30ths is. So I'm substituting in 6 and 4 on 30 wherever I see T in this equation. So everything's going okay so far. 1/6 pi. Instead of writing T, I'm going to write 6 and 4/30ths. And now it's just a case of putting all that into my graphics calculator. So make sure your calculator is in radians. I've got something like 0.366. And remember, this is in hours. Okay, so the number of daylight hours is less than half an hour in that day, which sort of makes sense because 6 and 4/30ths would be somewhere near this minimum point, which would be halfway through the year. Okay, so we think this is reasonable. If we wanted to, we could change this 0.366 into minutes and seconds, okay, by using this angle conversion tool. So 21 minutes, 23 seconds. Okay, not much time to do things during the day in that particular place. Part B, when and for how long will there be less than 5 hours of daylight? Give the answer to the correct date and month. So essentially we've got this same graph with 24 and 12 and 0. We want to know for how long will there be less than 5 hours. So I want to find what that length of time is where the daylight hours are less than 5. The way I'll do this is just using graphics calculator, putting this equation into my graph mode and putting y equals 5 into my graph mode and seeing how they both look. So I'll do that as a demo. So down to graph, put in both equations, got them both in the graph, press draw. I'll try a standard view window, maybe that'll help me out. I can see a little bit more. Yeah, that'll do for what I'm trying to find. If I was really intense, change this view window to between 0 and 25, so I get the whole day in. And I know my Y needs to go up to, say, 25 to get potentially 24 hours of daylight in there. That looks much better. Okay, just change the X value to maximum 12 just to get one full year. Okay. So I'm trying to find these intersection points. I'll just G-solve for the intersection point and I'll paste this onto my exam paper. So I really needed to solve this equation. Okay, I've now done it graphically. On my graphics calculator. So I know between t equals 3.86 and t equals 7.48, there will be less than 5 hours of sunlight. We can convert these into months and dates. I'll give the answer to the correct month and date. So this first one, 3 months. So I started at 1 Jan, so I need to go 3 months down. So I know I'm in April. And then I need to go 0.86 of 30 days into April. So 0.86 times 30 will give me how many days past the first that I need to go. So 25.8, which means I'll add 26 days onto here and get 27th of April as my first date where it's less than 5 hours of sunlight. Do the same thing for the other one. Okay, so we end up with between approximately 27th of April and the 15th of August, there will be less than 5 hours of sunlight. How long will this be for? We can just look at the difference between these two times. So difference between 7.48 months and 3.86 months will tell us how many months it's going to be less than 5 hours sunlight. So about 3.62 months. Okay, or we can change the 0.62 into roughly a number of days. About 3 months, 18 days. Alright, it asked any assumptions that we used. We made that assumption there, that there would be 30 days per month for the uniformity. Yeah, onto the question 2. Yeah, temperature in the town is known to be periodic in nature, and we're given a maximum and a minimum temperature. Need to make a model. So I'd start by just drawing a brief sketch in terms of how this looks. So it starts at 40.5, gets down to 7.1 degrees. So this is temperature, and this is time. So I'll just define my variables. Temperature in degrees Celsius. I'll let T be the time. Let this be months as well. So I know in January, 40.5. I'll assume that that's at the start of January as well. And I'm going to go for a period of 12 months, and it'll be back to 40.5 again. We know that in July, so again, I'll assume this is at the start of July. Okay, so pretty much at the 6 month mark, when exactly 6 months have passed, it's at the minimum temperature. So I'm also going to assume that it's sinusoidal. Okay, the periodic relationship could have been like this every time. Okay, we're assuming that it's one of these nice sinusoidal graphs. So develop a model for the temperature. Okay, when I look at this graph, I can see that it is one of these positive cosine graph, because it starts at its maximum. So I'm trying to fit it to y equals a cosine bx plus d, and now our job is just to find all these different letters. So to find a, which is the amplitude, the difference between the maximum and the minimum, and halve it. Yeah, that'll get me my A value. For B, we know the relationship is the period is 2 pi on B. I know my period is 12 hours. So 12B is 2 pi, or B is pi on 6. And to find D, the average value, okay, I'm going to find the average between the max and the min. Find those three values and I'll be able to substitute them in. So once I've found all these values, I'll just substitute them into my general model. So my model, I'm not using y's and x's, I'm using capital T's and little t's. So this is capital T, this is little t. My temperature will be 16.7 cosine of pi t on 6 plus 23.8. Okay, if you're weak with t's and t's, just change these so y is the temperature and x is the time. List the strengths and weaknesses of your model. Make a little table.
Strengths is that we can obviously use it to calculate the temperature at any time. And it's also good that we had exact values for the start and the middle of the year. So we used exact readings. Okay, for the start, middle, and end. In terms of weaknesses, one big weakness is that we assume all months are equal. Which means we might lose a little bit of accuracy for some of the months. And those assumptions we made at the start may be weaknesses as well. So that 40.5 degrees in January was really the average temperature for the month. Okay, so we used average temperatures for the month for Jan and July. We didn't have a temperature for a specific day. So to improve the model, we could have taken actual data for several days during the year and plotted it and ran a regression on it. But we're just trying to make a general model to see how the temperature changes during the year. Okay, so going into the last question, we need to solve this equation algebraically. And we're given a domain. And we're given a series of steps also to be able to factorize a cubic. So we're predominantly going to be following those steps. So I'll just rewrite the equation down here. I'll get confused with all these signs, so I'm going to let, say, m be sine x, just to simplify the equation for me. So 4m cubed plus 2m squared minus 2m minus 1 equals 0. So I'm going to basically follow the example. So it says group into pairs, and so that we can factorize each pair. Okay, so I'll just pair these first two up. Both of these are negative, so I'll have minus 2m plus 1. And then I'll see if I can take out any common factors in these first two terms. I think I've got a common factor of 2m squared. And I'm left over 2m plus 1 and minus 2m plus 1. So I'm pretty much at this point. I notice that they've seen that there's x plus 2's that are common, and the x squared and the 9 have come down. So I'll do a similar thing. I see the 2m plus 1 is common between both of these terms. And and what's left over is 2m squared minus, there's nothing in front here, so there's really a 1. Now that this equation is factorized, I can use my null factor law. So either 2m plus 1 equals 0, or 2m squared minus 1 equals 0. And I'll solve these, so m equals negative a half, or 2m squared is 1, m squared is a half, m is plus or minus square root of a half, which is plus or minus 1 on root 2. So from here, I've really got two solutions as well. So m equals positive 1 on root 2, and m equals negative 1 on root 2. Remembering that substitution I did, that m equals sine x, so I really need to solve the following three equations. So sine x equals minus a half, I need to solve sine x equals 1 on root 2, and I need to solve sine x equals minus 1 on root 2. So I'll do all that over the page. So I'm solving all three of these. If you got to this point, you should be pretty comfortable with these problems. So I'll just do the first one as a demo. The acute angle is which angle gives me a sine of a half. Okay, that angle is going to be pi on 3. I'm looking for where sine is negative. It's in quadrants 3 and 4. So I'll draw my unit circle, put pi on 3 off the x-axis in those two quadrants. I'll have pi plus pi on 3 and 2 pi minus pi on 3. So my solutions here will be 4 pi on 3 and 5 pi on 3. I can add 2 pi to both of these, but since my domain's 0 to 2 pi and my period is 2 pi, I'd be wasting my time. But feel free to go ahead. I'll just fill in the next two. So there's all our solutions, and then we'll just write them all together in some sort of ascending order. And there we go, there's our 6 solutions. How could we have made this question harder? Well, we could have put 2's in front of all of these, so you have the double angle going at the same time. Okay, but there are the 6 solutions that you should get. Okay, so just looking back on this when I was checking it, this should have been pi on 6, so that should be different, that should be different. These angles should be different, so where I see them in here, I should change those. So I'll go ahead and change all of them. You should do the same. So these are actually out of order now, so we'll just swap these two around to get all the solutions in the correct order. Okay, so it's a lesson for you to not take shortcuts and do things properly, and that's all the maps questions to have a go at.